Hi everyone! In this video, we're going to show how to use GeoGebra to verify derivatives as slope of tangent line. So first, we download GeoGebra Classic 6 and launch it. And then you can right-click here to choose whether you can hide the grid lines or you want the grid lines, but we can also do like graphic. You can have the major grid lines or on the major and the minors, okay? So next, we want to input a function. So at the input, we click here and let's type in our function. Let's say f of x equals, I want 3x to the 5 and minus 20 x cubed and plus 2. I want to make a rational function, so I use this to divide it by 5x to the 4th plus e to the x. Okay, so this is my function. Okay, let me make it smaller. You can input any function as you like. Next, I want to make a point that travel on this curve. So I want to create a slider. So how do we create a slider? Do you see this button? A equals to 2. So this is a slider. We click here and then it will help us to build. So we're gonna click here. Then we can build a slider there. And the name, let's call the name A, and I want my sliders to go from the x values is from minus 10 to maybe 20, and with the increment, let's do 0.1 here. Okay, so we click OK, and then the slider is right here. Okay. And after we have the slider, we can use that slider to put a point there. So in the input label, we enter the point A equals A f of A. Then when I move the slider, you can see the point also move with me. All right. Okay. And if you want to change the color of the point, you can always right click and then choose setting. So you can choose the color to be any color you like. All right. Okay. Oops, sorry. Okay, so here when you click anything there, all right, so you can see when I move, the points also move with me. And then next we want to draw the tangent line passing through this point. So how do we draw it? We click here, the line. Okay, and then you see this tangent option. So we click the tangent, then we click the point. So we click the point and we click the graph. So here we have the tangent line. All right, so we can also choose the color. So change the color of the line. So what color do you want? How about purple? Okay, so you can see when I move my slider, my points move and the tangent line also moves. Okay. So you can also change the setting to make the tangent line to be like other style, maybe thicker, or the style can be a dashed line or a solid line as you like. Okay. So next, I want to calculate the slope of the tangent line. So what do we do is in the input label, we insert s equals slope of the line G. So you can see our tangent line is G. So you can see this is the slope. All right, as A varies, the point varies, and the slope varies as well. Okay. So if we want to plot the points corresponding to the slope, what do we do? So in the input label, we insert let B be we want to have the x values of a, which is like a. So we want to have x values being the a, and the and then we have s. Okay, so the y coordinate is the s, the slope. All right, so let's see. And so when we move the points, you can see the point B also moves. Okay, so let's change color of the point B. Let's use red. Okay, so you can see when the A moves, and then we have the slope, and point A and point B moves. So we can right click the point B and we can show the chase. Okay, then you can right click clear to click the animation on. So you can see it chase so point B corresponds to the slope of the tangent. All right, so keep this picture in mind. Okay, next, finally, how do we find the derivative? All right, so in the inputs label, we insert derivative. So you can see it actually put up some functions for you. So it's derivative of function. So our function is f of x. Okay, so can you see after we enter, let me change this color to, how about yellow? Okay, so let's change to yellow. Now what happened? So I let the animation on, I turn it on, and then you can see the point B. How do we find the point B? We find the point B by calculating the slope of the tangent line. Now you see the chase, the curve, the trajectory actually match with the derivative. So now we have verified that derivative is the slope of the tangent line. Okay, and that's it for our projects. And then how do we share our projects to public? Okay, so here, the right upper corner, you see this 3 horizontal line. You can click save or you can click share. So how do we share? It actually requires you to sign in on GeoGebra, but if you have Google accounts or Microsoft accounts, you can always do that. So let me write down my Google account. Okay, so see, now I can save it. So I can save it as calculus 1. This is use GeoGebra to verify derivatives as slope of tangents. Okay, and here I can save it, and I can also share it. So okay, so here it can generate a link. Okay, so I can copy this link and then I can email anyone with the link can see this project. Okay, so let me see. So sometimes it's also because here you need to do shared, and then anybody with the link can see it. Let me see. So because the previous steps I didn't see these options here, so let's save it again. So this is use GeoGebra to verify derivatives as slope tangent. Okay, and save. Okay, so let's see. So let's open a web browser. and let's open a web browser and let's copy the link. Alright, so now after I open a web browser and I copy that link, let's see. Can we see the project here? Alright, I think let's do it again. So, share. So, okay, with this link. Alright, so let's do it again. Yes, it's right here. So we have successfully shared the project to the public. Anyone with the link can see your projects. Bye!